Welcome back to Historical Geology. So this will be the last lecture in the mobile belts for Laurentia during the Paleozoic, chapter 11 in this case, and parts of chapter 10. So here we're going to look at West Laurentia, or the west coast of North America, and here we're going to experience three orogenies. The third one is the Nevadan orogeny, which really occurs in the Mesozoic, so we'll leave that for later. But the two I want to focus on is the Antler orogeny and the Sonoma orogeny, and these two are occurring in Paleozoic time. So the Antler orogeny is late Devonian to early Mississippian, around 360 million years old, and what's happening here is we're going to accrete an island arc onto western Laurentia. And then for the Sonoma orogeny, we're going to accrete a small microplate, almost like an Avalonia, to the west coast as well, and this is another island arc, maybe microplate accretion at the Permian-Triassic boundary right around 250 million years ago. Now, before we get started there, just like we saw over in East Laurentia, where we open the Iapetus Ocean, here we're going to open the Paleo-Pacific Ocean by rifting Rodinia around 750 million years ago, right? So we rift Rodinia, and really, remember, we have East Antarctica. We have good evidence now that East Antarctica was up against really kind of the Death Valley region of California, but we're going to rift East Antarctica, Australia, New Zealand away and make the Paleo-Pacific Ocean. And in California, the sediments that end up being deposited in this basin is that Pahrump group of Death Valley. Remember the Crystal Springs Formation, the Horse Thief Formation, the Beck Springs Formation, and then that Kingston Peak Formation, which documents the snowball earth that we talked about. And again, what's going on here is after rifting Rodinia, we're going to develop a stable trailing continental margin, right? So a passive margin like we have on the East Coast today. So here's a little map showing the future zone of rifting. So we're starting to kind of break up the continent here. Here's Laurentia. Here would be Antarctica, Australia over here, parts of Gondwana during the Mesoproterozoic, and we're starting to deposit that Pahrump group. Remember, while the Pahrump group is deposited here, over in Arizona by the Grand Canyon, we have that Unkar group being formed there. And then as we go along, this is the same image we saw for the Iapetus Ocean, but over here we're forming the Paleo-Pacific. The key thing is we have a passive margin, but note that out here we're going to develop an island arc begins to form out in this Paleo-Pacific Ocean. Right, so we have the passive margin, and what we're seeing along the craton of Laurentia, we see quartz sandstones, carbonates, and we see all those rocks in the Death Valley region, in the Nopal Range, the Ivanpah Mountains of the eastern Mojave Desert, again telling us that we have a passive stable continental platform or passive margin. And then other sediments we see along this margin, we have those carbonates here, this carbonate sequences, but then farther out we end up seeing this Harmony Fan, which is late Cambrian Harmony Fan, and in this Harmony Fan there are deep marine cherts. A chert is it's made out of microcrystalline quartz, a little planktonic organism making this chert, and that's going to be one of the key components that's going to be part of the shoe fly formation. And we see that shoe fly formation in the Sierra Nevada, which is telling us about this ancient deep abyssal fan or Harmony Fan that was off the coast of North America in deeper waters. Now this line here, which is the edge of the craton, and we call it the 706 isopleth, and all that means is when we look at strontium isotopes, the lower the strontium isotopes, the more depleted the source. That's because older craton has lots of rubidium, because rubidium decays to strontium, and so the values of strontium on the craton for the basalt lavas that erupt in here, they have higher or elevated values because they're being contaminated by all that radiogenic strontium that developed from the rubidium in the old Precambrian rocks. Whereas everything to the west of this strontium isopleth line, 706 line, are going to have lower values than 0.706 because this is pretty much a new material, not contaminated by old rubidium decaying to strontium over here, right? So this is all new stuff. So we can map out the edge of the continent by finding this 0.706 strontium line. So a cross-section of that map shows that here we have the Laurentian, the Precambrian craton, the core here. And then we have the platform sediments, so Precambrian quartz classics. So that would be kind of our Beck Springs, maybe our Noonday Dolomite, Johnny quartzite in here, forming on this passive margin. And then what we see out here in this deep basin, that Harmony Fan, right, which is going to be that shoe fly complex we see up in the northern Sierra Nevada. And then off to the west, we have that Island Arc. And it's called the Alexander Terrane up in Alaska, but here in California, and we call it the Northern Sierra Terrane, which is a series of Island Arc volcanic rocks. And note subduction was going under the arc, so we call that reverse polarity. Instead of being under North America, it's under these island arcs. And eventually, when these arcs collide with North America, they're going to be accreted, and that's going to be the antler orogeny around 360 million years ago, middle to late Devonian. So we accrete the antler orogeny over here on the west side of Laurentia. And so a classic place to see the Northern Sierra Terrane is the Sierra Buttes Formation up in the Northern Sierra, right off of Downeyville, Sierra City, off of Highway 49, all those metavolcanic rocks, and there's even some ammonite fossils that date to the Devonian period that were found in the sediments around this island arc. So imagine a island arc volcano, Japan being thrust onto China. So that's kind of what happened here. We had this island arc thrust onto North America, and the fault where we can find that thrusting event is called the Roberts Mountain Thrust. Sometimes it's called the Roberts Mountain Allochthon. So the Roberts Mountain Thrust documents that thrusting event, that collision between these Sierra Buttes island arcs or Northern Sierra Terrane with North America. And so here's another image showing late Devonian around 370, 360 million years ago. So again, here's that 0.706 line for strontium, and then here's those island arcs. Note that the trench is here, which means subduction is going underneath toward the west, right? And then we're going to crash these onto North America in that antler orogeny. So here are the Sierra Buttes Formation, which is a glacially carved ridge called an arête. And up off of Highway 49, here's some of the Gold Lakes Basin down here, very beautiful area. And there's a lookout tower up in here where you can climb up there. And these are all island arc rocks. Some are pillow lavas, but all andesitic kind of stratovolcano rocks here. Devonian Island Arc here. So the next orogeny is going to be the Sonoma orogeny, and that's going to be Permian Triassic, right around 250 million years, 300 million years ago. And again, in this little cartoon I have here, I've accreted the shoe fly, which was that basinal sediment that occurred before the Sierra Buttes Northern Sierra Terrane. We accreted that in the antler orogeny. We have the Roberts Mountain Thrust here, but now we're depositing marine chert, maybe some limestones over here in a basin, and that's going to be a rock unit we find here in California called the Calaveras Complex. One of the best places to see this is in Calaveras County, right off the Merced River there. As you're going from Mariposa on Highway 120 up to Yosemite, you'll see all these Calaveras limestones and cherts, and there's conodont fossils in there as well that tell us about this late Paleozoic age for the Calaveras Complex. And then we have these Sonoma Island Arcs, maybe a little microplate, but there's another series of island arcs offshore. And again, note that we have this reverse polarity or subduction under the arcs going westward. There's no subduction under North America, at least not yet. And so here's a little cartoon 250 million years ago, which is right at the Permian Triassic boundary. And so again, we're seeing the Calaveras complex forming in here. And it's a little confusing here because here they're showing subduction going underneath, going toward the east here, right? So, but on the cartoons you see over here, we see the Calaveras complex subduction under the Sonoma Island Arcs. And note that once this little microplate or these island arcs are accreted to North America, this called the Golconda terrane. Well, another word we use for it is a Golconda thrust. So remember, for the antler orogeny, it was a Roberts Mountain Thrust. For the Sonoma orogeny, it's a Golconda Thrust. And this is taken right off of Highway 120. This is the Merced River right before you enter Yosemite. And these are all these limestones and cherts that are all folded that were being deposited in this basin between North America and these encroaching Sonoma Island Arcs. So we have those sedimentary rocks right here in California. And then this kind of is a culmination of the Sonoma orogeny, 250 to 210 million years ago. We accrete those island arcs plus the intervening sedimentary rocks of the Calaveras Complex. So here we have that flysch, right? Remember that deeper water basin sediment all in here. We're going to add it to the passive margin over here where we have the older antler belt in here, antler orogeny. And then Permian Sonoma Arc approaches North America, subduction to the west, right? Subduction to the west. So here's an important point. By the time Sonomia and the called Conda thrust happens, note that for the first time we see Cordilleran subduction. In other words, subduction is going under North America toward the east. So note that when we start seeing the first time, that's going to be in the Triassic. Sonoma Flysch Belt is thrust over North America, over that passive margin. The new arc formed with subduction to the east, beginning the active Cordilleran margin. So now we're going to start forming the Sierra Nevada and all the associated rocks that we are familiar with today. All right, well, so we'll stop here.